In this video we are gonna see how the rainbow is formed. First we need the sun and we need drops of water. That's the sun and that's a drop of water. Now we need a sun ray. And of course we need an observer. We are going to observe from here. Now, the sun ray, the sunlight, has all the colors of the rainbow, but we are gonna work here only with three colors: red, blue and green. Now, light refracts when it changes medium. When it changes from air to water, light refracts. Refraction of light means a change in the direction of propagation. So light changes direction when it changes medium. But not all the colors of light refract in the same way. They refract according to their frequency. The higher frequencies refract more, so change that direction more than the lower frequencies. So red is the lowest frequency and changes direction less than the other colors. So let's see what happens to the red color of light. So here it has changed direction, but very slightly. Now when the red color gets to the other side of the water drop, it reflects. Reflection is what happens in a mirror. It bounces back. And now it changes direction again. It refracts again, changing medium, so it gets to the observer. So the observer sees the red color. But let's see what happens to the other colors. Let's take green, that is the second frequency, the second lowest frequency that we are considering here. Remember that we are considering only three colors, though the rainbow has all the colors. The light, the white light of the sun contains all colors, but we are using here only three for the sake of simplicity. Let's take the green color now. Green color refracts more than red color, so it changes direction a little bit further, a little bit more, and now it reflects and refracts again. That reflected beam doesn't reach to the observer, so we don't see the green color. Let's see what happens to blue now. Blue refracts even more than red and green, so it would go like that. Now it reflects the same as all the other colors and refracts again. So it gets lost, so we don't see the blue color either. We see just the red color, not green, not blue. Of course, we have to say that there are part of these colors that refract here again, and they continue its way. But there's a part of them that goes that way. But we don't care about those because we have no way of seeing those. But there would be part of the colors, part of the light that is lost on the other side. We are gonna forget about those because we cannot see them. So we keep the part that is on our side, on the side of the observer. So we say that we see only the red color, but that is referring to this drop of water, this droplet. Because we have more drops of water. Obviously, we have another drop of water here, and on this drop of water, on the surface of that drop of water and in the inside, is the same thing is happening, the same thing and in the one on top. So another ray is coming from the sun. The red, green and blue colors are refracting, reflecting, and now refracting again. But in this case, the ray, the color that reaches the observer, is the green color. It has the right angle to reach the observer. And the same thing is happening in all drops of water. So we have a drop of water below, and the same thing is happening. The sun ray is coming, is reflecting and refracting, and in this case is the blue color, the one that reaches the observer. So the observer is watching a blue color here, a green color here, and a red color here. And of course this is happening for all the colors, not just red, green and blue. So the observer is watching all the colors in different positions, one on top of the other. On top of everything is the red color, and under all the colors is, well, actually not blue, it would be violet. Purple color would be here, because purple color is the highest frequency and that refracts even more than blue. But I don't have violet here, so I have worked this out with just red, green and blue. So that's why we see the colors in that order: red on top of the rainbow, green like below red, and blue even lower. And that's why the order of the colors is like that, according to their frequencies. The lowest frequency higher up, and the highest frequency lower down. But now, why does the rainbow have that shape? The shape of a bow, the shape of a circumference arc? Well, let's see that with just one color, to make it simpler, because it's the same for all colors. So let's keep, for instance, red. So we keep the red color, and well, this angle here is 42 degrees. That can be calculated, and we'll do it in a separate video, but that's not the angle we are gonna use. We are gonna use this angle instead. We don't know for certain what that angle is. There's no way of finding that, because we don't know exactly. It depends on the angle of the sun. So that angle varies, but in a certain moment when the rainbow appears, that angle is fixed, because the sun angle is fixed in that moment. It's a certain angle. So that's the angle that we are going to consider. So the red color is seen with this angle with respect to the horizon. We are gonna copy that angle here. This is the horizon, and that is the angle. That is the angle for the red color. And now we fold this sheet according to that angle. Let's change the perspective. Now we are looking at the rainbow face to face, like this, and the red color is coming from all those points, because if we rotate that angle, the red color is coming from all those points. So let's draw a semicircle. And that would be the red color. For the blue color we would have a lower angle, so we could do the same. We would rotate and we would have the bow for the blue color, and the same for the green and the rest of the colors. So that's why we see the colors of the rainbow in a bow, as if it were a bow, a circumference arc. Actually it's half a circumference, half a circle, because the horizon cuts the other side. It is raining just here. We don't have rain under the earth. So that's why we have only half a circle. Actually, if we were flying on an airplane, we could see the whole circle of the rainbow. Someone who's next to us would see a different rainbow. This person would see his own rainbow. So no matter how we move, the rainbow is always centered around us, around our head, and opposite to the sun. So we have the sun behind us, right behind us, and the rainbow opposite to the sun, so in front of us. If we were higher up, flying in an airplane, we could see the whole rainbow, a whole circle, like this, because in this case the horizon doesn't cut the rain, so it doesn't cut the reflection of the colors.